Hello friends, it's your old pal, Mr. Carlino. Thank you for taking a look at this video on inscribed angles. Should be on packet page 21. Quick little review. Remember we talked about central angles, where the vertice of the angle was the center of the circle, and that angle could be found by taking the measure of its intercepted arc. Now we're going to talk about what makes an inscribed angle in a circle. Well, the vertice is not the center of the circle anymore. The vertice is actually on the circle. So take a look at this angle right here, which I'll call ABC. Notice now the vertice is not the center of the circle, it's actually on the circle. So this makes it an inscribed angle. And you will also notice the sides of the angle are chords of the circle. AB and BC are chords. Another way we can do it, as you remember, the longest chord in a circle is called the diameter. So an inscribed angle could also be formed using the diameter, not just two chords in the circle. I'll call this one DEF. Right, so again, difference between central angle, the vertice is on the center versus inscribed angle. Now the vertice is somewhere on the circle, and the two sides are formed by the two chords. Now, how do I find an inscribed angle? Well, inscribed angle is our first theorem of the day. Inscribed angle is not going to be equal to its arc measure. It's going to be equal to half the measure of the intercepted arc. So we're going to find what arc it makes, and we are going to take half of that arc. Right? So let's try to apply here. Let's take a look at some inscribed angles. You'll see triangle ABC. It says it's inscribed. If you remember back from the beginning of the unit, an inscribed polygon is where it's inside, but the vertices have to be touching the circle, which both A, B, and C are. All right, so let's go in order here. Let's find the arc BC. Right, arc BC. If you take a look at arc BC, you will see an inscribed angle A drawn to arc BC. Right, take a look at inscribed angle A that is drawn to arc BC. So what we're going to say is, all right, if it's formed from an inscribed angle, I know that inscribed angle 80 had to be half of whatever the arc was. So to go in reverse, I'm going to double it. Now I'm going to say arc BC now is not half of 80, but double 80. Or 160 degrees. All right, let's get rid of highlighting. All right, next on the table, we got angle B. So take a look right now at your diagram. You'll notice angle B, the vertice is on the circle, which makes it inscribed. So I know it's gonna be half of some arc. What arc? Well, I find where it's drawn to, and it looks like it's drawn to arc AC, which has a measure of 88 degrees. So angle B will be 44 degrees. 44 degrees. All right, from here now, do you need to use circle theorems to find angle C or arc AB? And the answer is absolutely not. Right, you can use your knowledge of how many degrees are in a triangle and how many degrees are in a circle. So we can look at angle C right now. All right, I have 2 out of the 3 angles in a triangle, so I can just say 180 minus 44 minus 80, and that will give me 56 degrees. And the same thing can be said for part D, finding arc AB. We already have 2 out of the 3 arcs to make up a total circle of 360, so we can take the 88 and the 160 we found in part A and subtract them from 360, and end up with 112 degrees. So a quick application of finding your inscribed angles. All right, let's go look a little bit more hardcore. Find the values of A and B. All right, so let's start with arc A. All right, let's start there. I see no central angles, but I see a ton of inscribed angles. So what I'm going to try to find in this diagram is there an inscribed angle drawn to arc A? And you better believe there is. Angle PQ T. See how that is an inscribed angle because Q is on the circle and it is drawn to arc PT or arc A, which is what we're trying to find. So if that's an inscribed angle, I know that's going to be half of whatever arc A is. So instead of taking half of it, I'm going to, just like I did in the previous problem, double 60 degrees. And arc A is going to be 120 degrees. All right. Now we go to angle B. Angle B, you'll notice where the vertice of angle B is. It's on the circle, so it will be inscribed. It might be a good idea sometimes just to highlight what angle we're talking about because there looks like a lot of angles coming from B. So PRS, it is inscribed, so I know it's going to be half of an arc. What arc in particular? Well, take a look here. Follow along. You'll see that the intercepted arc is PTS. Arc PTS. And it's very easy just to say, oh, that's 120 degrees, I just found it, but you also have to include this 30 degrees here. So it's actually a total of 150 we're going to take half of, not 120. And that will give me an arc, that will give me 75 degrees for angle B. Okay, so a little bit different might help to highlight your inscribed angles. In this box right here, I have a separate theorem from the diagram we just used. And here it is. It says if two inscribed angles drawn to the same arc what do you think? Pause the video if you need to. Two inscribed angles drawn to the same arc are congruent to each other. So if I take a quick diagram, put the center in, let's get a couple chords going, I'll put a diameter in. Let's label this A, C, B, and D. If you take a look, angles C and D are both inscribed angles, and they're both drawn to the same arc. Watch me highlight them here. Here's angle C, and here is angle D. Both inscribed because their vertices are on the circle, and look, they're both drawn to arc AB. So those are two inscribed angles drawn to the same arc. So I can say that both angles C, not arc, I can say both angle C and angle D are congruent to each other. And you'll notice, hey, it also works for angle A and angle B. Those are two inscribed angles drawn to the same arc. All right? And finally, all right, look at this big mamma jamma we got here. All right, find x, y, and z. AB is a diameter, great, and ABD is a straight line in case we were wondering. All right, let's start with x. All right, we'll go with x. I notice that is the inscribed angle, so it's going to be half of some arc here. All right, so let me just take my highlighter again, make sure I know what arc it's being drawn to. Here's angle x. It looks like it's being drawn to the diameter, so it looks like it's being drawn to a semicircle, which we know is 180 degrees. So angle x must be a 90-degree angle. All right, and then from there, we can find y pretty easily because we know 2 out of the 3 angles in the triangle. So 180 minus the 90 we just found, minus the 58 that was just given, will give us angle y, 32 degrees. Okay, it may be a little confusing here to what z is pointing to, but I will let you know that z is pointing to angle BCD. All right, that angle measurement right there. Now here's the trick. It looks like it's inscribed because the angle C is on the circle. But remember, the other part of the definition was not only does the vertice have to be on the circle, but also it's got to be containing, the other 2 sides of the angle have to be 2 chords. And I don't believe CD is a chord. I definitely agree BC is a chord, but CD is not a chord. So we got to work our way around this because the inscribed angle theorem will not work here. But if you can see, we have 58 degrees and angle CBD. Take a look at those two angles, 58 degrees and angle CBD. Little linear pair action that we have going on there. We know from Unit 2, linear pairs are supplementary. So you can find the angle next to 58. And then from there, you can have the angle next to 58 and 26. That forms a triangle, 2 out of the 3 angles. You can find angle BCD. So I'll give you a minute, and you can pause the video right now, because I'm about to write the answer down. So just pause the video real quick. And you should have found angle Z, angle BCD, to be 32 degrees. All right. Go back and take a look, because I want to talk about these 2 theorems that are down here. Take a look at how we found angle X. Angle X was an inscribed angle that was drawn to a semicircle. And now we have a theorem that we can use down here, that any inscribed angle of a triangle that intercepts a diameter or a semicircle forms a right angle. Okay, so from now on, especially when we're doing our proofs in our reasons column, if an inscribed angle intercepts a diameter or is drawn to a diameter, that angle is a right angle. And then there's another huge one right down below that I'd like you to take a look at, and we're going to draw a diagram to end it here. If you have any quadrilateral, all right, so go ahead, take a circle right now, right below. Any quadrilateral, doesn't matter what it is. Draw in nice quadrilateral. Get that bad boy. Any quadrilateral. As long as it's inscribed, and remember, inscribed just doesn't mean inside. The vertices have to be touching the circle. That the opposite angles will always be supplementary. So angle A plus angle C equals 180. And angle B plus angle D will equal 180 degrees. That is for any inscribed quadrilateral in a circle. All right, and then from here, bottom of page 23 is your homework assignment. Also, you can get a copy of the assignment sheet on Aspen if you'd like, but again, the homework matches what's at the bottom of page 23, and that's what you're going to be responsible for coming into class Tuesday, 8th period. All right, hopefully you enjoyed the show.